Welcome to our Unit 5 study guide number 1 in preparation for the Unit 5 exam. We have 8 questions that we'll do together, and let's start with number 1. Okay, so we're dealing with fraction exponents here, and we want to remember how fraction exponents work. So when we have a fraction up here, we can rewrite this as, let's keep x as the base. P will stay the power, and then the denominator, which is r in this case, comes outside as the root of the function. Okay? So for example, in A, 125 to the power of 2/3 gets rewritten as the cubed root, see I took the denominator out, of 125 squared. Okay, so it's time to simplify this. Now, you can do it one of two ways. You can do 125 squared first and then take the cubed root, or you can take the cubed root of 125 and then square it. This will be my preferred method because, let's admit, this takes us to really big numbers that we can't do easily by hand. So I'm going to go ahead and take the cubed root of 125 first. That would be 5. And then in the last step, so essentially what I'm doing is this. In the last step, I'll square that 5 to get 25. So now that we have a little practice, let's do the second one a little faster. Okay, part B says 36 to the 3/2 power. So let's rewrite that. That's going to be the square root of 36 cubed. The square root of 36 is 6. And then 6 cubed is, I think it's 216. Check my math on that, please. All right, part C. Now we have negative 27 to the 2/3. Okay. I just checked my math. Okay, this was good. All right, moving on. So negative 27 to the 2/3. So here's the interesting thing about that negative there. It is not inside my parentheses. So that means I'm not taking the cubed root of negative 27 and then squaring it. That's not what's happening. Instead, since there is no parentheses here, I just add that negative on at the very end. Okay, so I'm only taking 27 to the 2/3 power. This is like writing negative 1 times 27 to the 2/3. Okay, so we're going to take the cubed root of 27 and then square it. Cubed root of 27 is 3, and then 3 squared is 9. So what I just did there was this inside portion, but don't forget we have a negative 1 outside. I'll highlight it here, I'll highlight it over here. So our true answer is bringing down the negative, and then this was 9. Okay, part D. Doing 9 to the 1/2. So that's going to be the square root of 9 to the 1, which is 3. 3 to the 1 is just 3. So this is one of those famous ones. Anytime you have something to the power of 1/2, it's really just a square root. Right? So 121 to the 1/2 is 11, right? The square root of 121. 36 to the 1/2 is 6, just the square root of 36. All right, so that's number 1. Let's go to number 2. So if f of x is x to the 1/2, then our job is to find, let's start with A, f of 121 m to the 4 z to the 9. So the first thing you want to do is take this and plug it into the correct function. So that means I'm going to be rewriting instead of writing x to the 1/2, I'm replacing x with all this stuff. 121 m to the 4 z to the 9 all to the 1/2. All right. So that means that I'm taking the square root of all this. So we're going to take the square root of each factor, or each piece that's being multiplied here. And there are 3 of them. 1, 2, 3. We'll take the square root of them all separately. So the square root of 121 would be 11. Now the square root of m to the 4, think about it. If I have 4 m's, and I'm pulling them out in groups of 2, because that's the invisible number there, then I'm pulling out 2 pairs. So that means the square root of m to the 4th would be 11m squared, to represent 1m to represent the first group, and then that second m to represent the second group that we pulled out. There are no leftovers, notice, so I don't have to leave any inside. There are none left over. All right, now the square root of z to the 9th. So we're trying to find out how many pairs of z's to pull out. If it's helpful to write out the 9 z's, that's totally fine. We can do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to be pulling out 1, 2, 3, 4 pairs of z's. So many of you probably already knew that. Since there are 9, I can take out I can take out 4 pairs, because that would be 8 of them. So that means I'm pulling out not 1 z, not 2, not 3, but 4. Z to the 4th. And there is this 1 left over because it's an odd number. So that would be our leftover guy. Okay. That would be our answer. To A. Now let's do B. So f of negative 81 ab to the 6th means I'm taking all this and plugging it into my f function. So I'm taking it to the power of 1/2. So again, the power of 1/2 means the square root. And we will do it each separately. So the square root of a negative 81 is going to be 9i. Now the square root of a, well, there's only 1 in there, and I need to pull things out in groups of 2. So I don't have enough to pull any a's out, so that a remains inside the square root. And now I have b to the 6th. Well, if I have 6 b's in total, and I'm pulling out groups of 2, that means 3 pairs will come out together, and none will be left inside. To demonstrate this, I can show you 1, 2, 3 pairs will escape with none left over. And that's why I'm not putting any b's in here, because they're all gone. They all left. This would be our final answer for part B. Okay, last but not least, let's do C. For C, we have f of 8p cubed q to the 6th. That's all under square root, or I should write to the power of 1/2 first, plugging it into my function, and then that means I'm doing 8p cubed q to the 6th. All right, let's take the square root of 8 first. So unlike the previous 2 examples, this 8 is not a perfect square. So we're going to need to simplify. So 2 goes into 8 4 times, 2 goes into 4 2 times. So as you can see, I'm pulling out groups of 2. And I'm left with a single 2 right here. This would be like my loner. Okay. Next, I'm dealing with p cubed. and I'm pulling out groups of 2, so one p will escape, and I'll be left with a single p inside. And now I'm dealing with 6 q's, so I'll pull out 1, 2, 3 pairs, and none left over. So this is all very awkwardly written, and that's because we usually write the outside numbers all next to each other. So it'd be 2pq cubed, and then the inside numbers left inside the radical also multiply together, just like that. And that would be our final answer. Okay, now we're moving on to number 3. So they're giving us f, that is right here. They're giving us our g function, which is right here. And we're being asked to add them together. So specifically what I'm adding together is this expression, 3 minus root 5, and this expression, 4 plus 2 root 5. So I'm going to write it first of all. Basically replace f of a with 3 minus root 5. I'm going to use my plus sign, and then my g expression. All right. So when we are adding and subtracting radical expressions, we are going to treat them like terms. So here's what I mean by like terms. Square root of 5 and the square root of 5 are like terms, whereas maybe 2 root 3 and 5 root 6, these are not like terms, so I would not combine the 2 and the 5. Okay, so in this case, I have 3 plus 4 gives me 7, and then I have negative 1 root 5 plus 2 root 5. So I'm going to add my coefficients. Negative 1 plus 2 gives me plus 1, and then root 5. It's almost like these are x values. That's 3 minus x plus 4 plus 2x. So these guys combined, and then minus 1x and plus 2x went together to give me plus 1. And instead of x, I'm dealing with radicals. Okay, let's do b. Now I want to take g of a, which is 4 plus 2 root 5, and then subtract from that f of a, which is this binomial expression. So I need to use parentheses to make sure I'm subtracting both pieces. All right, a negative outside means we need to distribute it in. So I have 4 plus 2 root 5 minus 3 plus negative times 9 makes it positive, root 5. So we'll combine our like terms again. Now remember, when we're combining like terms, we add and subtract. We're not multiplying. So 4 minus 3 gives me 1. And then I have to check, are these like terms? Indeed they are. So this is 2 root 5 plus 1 root 5, which gives me 3 root 5. And that's our answer. Looking at C now, I have negative 4 times f of a. So what is f of a? I need to plug that in. Well, it's 3 minus root 5. Now I will distribute. Notice how, again, I used parentheses because I want to make sure that negative 4 here gets multiplied to both terms of f of a. Both of them. So, multiplying in, that's negative 12, and negative 4 times negative root 5 is giving me plus 4 root 5. So this was the first time where we're actually multiplying. And what I did was I multiplied the outside numbers together to get plus 4, and then the root 5 just stayed on its own. Let's do one more example, D. So now I'm taking f of a times g of a. So I'm going to multiply them together. So f of a is 3 minus root 5. And I need to multiply that with g of a, which is 4 plus 2 root 5. All right, let's practice. We need to FOIL. So 3 times 4 is going to give me 12. 3 times plus 2 root 5, so the outside numbers again multiply. That gives me plus 6 root 5. Next, I have minus root 5 times 4. So that's minus 4 root 5. And finally, I've got negative root 5 times positive 2 root 5. So it leaves me with minus 2 because of the 2 and the negative 1 here multiplying. And then I have root 5 times root 5, which multiply together inside, giving me the square root of 25. So you should immediately recognize right now that the square root of 25 is just going to equal 5. Right? So the square root of 5 times square root of 5. I could write this, or you can directly go to that step. That's the rule. If you multiply a root by itself, a square root specifically, then you just are left with the stuff inside. So root 11 times root 11, for example, is just 11. I skipped the middle step of writing square root of 121. Okay, so that's a sidebar. But we can show our work. Let's continue. I have 12, and I'm noticing I have some like terms here. Plus 6 root 5 minus 4 root 5. Now I'm done multiplying, right? This was my multiplication step. Now I'm combining like terms, because it's all addition and subtraction now. So that leaves me with plus 2 root 5. And then finally I have minus 2 times 5, which is minus 10. So we'll finish up. 12 minus 10 is 2. And my final answer is 2 plus 2 root 5. Okay, number 4. We're given a rectangle. We want to find the area and the perimeter. So let's start with their area formula, which is length times width. So it doesn't matter which one you make your length, which one you make your width. We're just going to multiply them together, and that will be our area expression. So if I say 6 plus square root 3 is my length, my width would be 8 minus root 3. And keeping in mind we're using parentheses, so we're going to need to FOIL this out. So 6 times 8 is 48. 6 times negative root 3 is minus 6 root 3. Root 3 times 8 is plus 8 root 3. And very carefully, okay, we have a positive times a negative, which means I'm negative in my answer. And then root 3 times root 3 is just going to be 3. You could write square root 9 because these numbers multiply inside the radical, but recognize that that will just simplify to 3 in your next step. Next, let's combine like terms. So we have minus 6 root 3 plus 8 root 3 gives me minus 6 plus 8 is 2 root 3. And then 48 minus 3 gives me 45. So I could write it like this. Or my answer could have been 45 plus 2 root 3. They're the same. They're both equivalent because both of them are positive. Now let's talk about the perimeter. So our perimeter formula is take your all sides and add them together. Okay, so we could write it like this. 6 plus root 3 plus 8 minus root 3. That gives me this plus this. So I still need the other two sides. So I'll write them again. Plus 6 plus root 3 plus 8 minus root 3. Right, that's one way of doing it. The faster way of doing this perimeter problem, though, is to recognize that I have two of the same side length. So I'm going to take my length and multiply it by 2. And then I'm going to add that to my width times 2 to show both sides. So I'm going to plug it into, I'm going to use the second one because it's a little more just challenging. We have multiplication and addition, so let's practice plugging in. So my length in this case is 6 plus root 3. And then my width would be 8 minus root 3. But please understand that this method, number 1, and this method, number 2, will give us the same solution. All right, so using method number 2, let's distribute our 2. We get 12 plus 2 root 3. Now we're going to distribute the second 2. That's plus 16 minus 2 root 3. And now we will combine like terms. So I have 12 plus 16 gives me 28. And then 2 root 3 minus 2 root 3 cancel each other out. And this is my perimeter. 28 units if you want to be especially awesome. Same here. Whoops. The answer would have been like 2 root 3 plus 45 units. Okay, let's go to the next problem. Radical equations. So for solving radical equations, right now we have 2 square roots on either side of the equal sign. So the first step we can do in this case is just square both sides. Notice how I'm using parentheses. This is going to become very, very important. Okay, so anytime you square anything on either side of the equation, you need to use parentheses. And you need to get the entire side. Okay, you can't just pick, like if I have a plus b equals c, and I want to square both sides, I can't just decide, oh, like this, without parentheses, because that means only b is being squared. You've got to go whoop, and square the entire thing. That would be a plus b times a plus b, and then FOIL. Okay, this is going to come up later, but keep it in mind. Use parentheses, please. So when I square the left side, the radical disappears. I'm left with 6m minus 3. When I square the right side, the square root disappears, and I'm left with m plus 22. Since this is not a quadratic equation, notice there are no squared symbols. Okay, so since it's not a quadratic equation, I'm just going to isolate m. Right, so I just want to solve for m. So I'll bring my m's to the left, minus m. I'm left with 5m minus 3 equals 22. And then I want to move that 3 to the other side. I'm left with 5m equals 25. And my final step, divide by 5. I get m equals 5. But that's not enough. I always, whenever dealing with radical equations, have to check for extraneous solutions. So I'm going to check for m equals 5. So let's go back and look at our original equation. Everywhere that says m, that's 1, 2 spots, I need to plug in 5. So this is the square root of 6 times 5 minus 3 equals the square root of 5 plus 22. The most common mistakes kids make is only plugging it into the first spot that they see, and then the other one leaving it as m, which is incorrect. It needs to be plugged in. So there should be no variables at this point when plugging in. So if you see an m still in your equation, you need to go back and plug in 5 instead. All right, so let's simplify. 6 times 5 is 30, and 30 minus 3 is 27. Let's see if that equals the right side. Well, 5 plus 22 is square root of 27. my left-hand side and my right-hand side are equal, so this checks out. So my answer is not root 27. Please understand that's just a check. Our answer was m equals 5 is a valid solution. Right? M equals 5 would be the answer. All right, let's do number 6. Solve the equation. So, again, we're going to go ahead and square both sides because my radical's already all isolated by itself. But I like to rewrite so my variable I'm solving for is on the left side of the equal sign. So I'm going to write equals 7 on the right here. And then I'll go ahead and square both sides. Okay, so remember we need parentheses around everything on both sides. So on the left, when I square a square root, these cancel. I'm left with 8c minus 1 equals. On the right, 7 squared becomes 49. So let's solve, okay? Solve for c. This is a straightforward get c all by itself since it is not a quadratic equation. You don't see any powers over here. So let's add the 1 to both sides. I get 8c equals 50. And I'll divide both sides by 8 to get c equals 50 over 8, which actually simplifies to 25. I'm cutting the top and bottom in half. 25 over 4. So it seems that my answer is going to be 25 over 4, but before I put a box around it, I need to check. So let's go to the side. We need to make sure we're not getting an extraneous solution. So that means I'm going to plug it into my original function everywhere I see a c, which is only in one spot. So let's do it. That's the square root of 8 times 25 over 4 minus 1. Set that equal to 7. Okay. So first I need to do this multiplication here. So to multiply fractions, we put it over 1. And then notice the 8 and the 4 can cancel into 2 over 1. And so 8 times 25 over 4 becomes 50. I multiply my numerators over 1, which is just 50. Minus 1 goes under square root. Next, this 50 minus 1 is the square root of 49, which is 7. And so since this is a true statement, we put a check mark by it. But our answer is not 7. Our answer was 25 over 4. We checked it. It's a valid solution. All right, number 7 says, what is the extraneous solution for the following? So again, my radical expression, this guy right here, is already isolated. It's all by itself on its own side of the equal sign. So that means that we get to square both sides right away. So, oh my God, parentheses, super important. Put parentheses on the left and square, and parentheses around everything on the right, and take it to the second power. So this problem is really interesting. Lots of common mistakes happening here. On the left side, when you square a square root, that will cancel. So 7p plus 11 is what remains. On the right side, however, we have some work to do. So I have to multiply p minus 1 times itself. So that means I have to write it out twice. That's p minus 1 times p minus 1. And I will now FOIL. So that's going to be p squared. Okay, p squared minus 1p, and then minus 1p again, and then plus 1. You have to FOIL very, very carefully. Once you're done FOILing, so let's copy down the left side. We had 7p plus 11. So once you're done foiling, it's time now to combine like terms. Let's clean up the right side over here. So minus 1p leaves me with p squared minus 2p plus 1. On the left, still 7p plus 11. So recognize that at this point, what we're dealing with is a quadratic equation. This is the first problem that we have like this, where you actually see the variable being squared. So, So since we have a quadratic equation, the way to solve is to get all terms on the same side, set everything equal to 0, and then we can solve by factoring or other methods like the quadratic formula if factoring doesn't work. Whatever it is, we need to set everything equal to 0 first. So let's do that. So I'm going to go ahead and bring these terms over to my right side. So I'm going to minus 7p and minus 11 on both sides. I have to align them carefully. Minus 7p lines up with minus 2p. And minus 11 lines up with the 1. So on the left, these all cancel. And I'm left with p squared minus 9p minus 10 equal to 0. Now you can factor this. So everybody learns factoring differently. I'm going to go ahead and use magic X to fill this in. So I need two numbers that multiply to negative 10 and add up to negative 9. Those are going to be negative 10 and positive 1. So I have p minus 10 and then p plus 1 equal to 0. So from this, setting each factor equal to 0, I get p equals 10 as one solution, and p equals negative 1 as my second solution. So the question actually said, what is the extraneous solution? So I already know one of these, at least one, isn't going to work when plugged back in. So we're going to go ahead and do a check for p equals 10 and also a check for p equals negative 1. So we got to plug these in to our original equation. Not somewhere in the middle. You can't plug it in here. You can't plug it in here. Those are no-nos. You got to plug it into your original every time. So that's root 7p plus 11 equals p minus 1. I'm going to plug in p into two spots. Looks like, yeah, I got it. All right. So instead of p, I'm plugging in 10. So that's going to be 7 times 10. And then instead of p, again, we're writing 10 instead. So the right side simplifies to 9. Meanwhile, on the left side, 7 times 10 is 70. And then 70 plus 11 is 81. And the square root of 81 is 9. So this checks out. Okay, p equals 10 would be a valid solution. So it's actually not what I want for this question. The question's asking me for my extraneous solution, the one that doesn't work. So let's just make sure that it's the second one here by plugging it in. So instead of 7p plus 11, I'm writing 7 times negative 1 plus 11. Instead of p minus 1, I'm writing negative 1 minus 1. So these are the spots where I plugged it in. Let's simplify the left side. 7 times negative 1 is negative 70. Let's simplify the right side. Negative 1 minus 1 is negative 2. Now, without doing any more work, I already know that this is extraneous because the square root of something can't ever give me a negative number. right? The square root of like 25 is positive 5. The square root of a negative number is going to be 5i. But I will never get something like this. I'll never get the square root of something to equal negative. So I already know it's extraneous, but I will verify. So negative 70 plus 11 is negative 59. And the square root of negative 59 definitely is not equal to negative 2. That means p equals negative 1 is my extraneous solution. And it's the one that I would select or choose for this problem. Okay, let's go to 8. It wants me to write the equation for the graph. So the first thing to recognize about this graph is that this left graph, let's call it A. Let's call the right graph B. Okay, so the first thing to recognize about these graphs is that our parent function for A is our cubed root x function. That's the shape that it generally takes. It actually looks like this, right through the middle. But what's happening is this is a shifted version. It seems that it's going up 1 and over 2 to get to our new center from 0, 0 to this spot right here at 2, 1. Right? So, but recognizing the parent function is the most important thing. For B, our parent function is the square root function. So now our challenge is just to identify these critical points. So labeling is super helpful. That's 2, 1. And this one over here is 1, 2. Now the way critical points operate is we rewrite, so it's going to be cubed root of x. So since we flip the inside number to get our x coordinate right here, I'm going to write minus 2. And then to get our outside number, it's the 1 being added on the outside. We don't flip the sign or anything, we just write plus 1. This shows that I'm being shifted 2 units to the right, and this shows that I'm being shifted 1 unit up, which is what's happening. I'm going to the right and then I'm going up. So, last thing to check, is this being flipped? Well, since it's our normal S curve, this is not being flipped, so that's going to be a positive outside. On the other hand, if our graph looked like this, then we would stick a negative in front of our cubed root. So our final answer then is f of x equals the cubed root of x minus 2 plus 1. Okay, let's go to B. So same ideas apply. So we're dealing with a square root function. So inside of our square root will be the opposite of positive 1, which is negative 1. And then outside, to show that we're shifting 2 units up, we're going to write plus 2. And that would take us, if we were to go backwards from this, to our critical point of 1, 2. Now it's time to check if it's being reflected. Well, this is the general shape of our square root graph. So it's not being flipped, since it's not going downwards. It's going to be our positive version and not the negative. So you could put a plus out in front, or you could just leave it. But our function is going to be square root of x minus 1 plus 2. And that would be the answer for B. So I hope that this video was helpful. Good luck with your group test tomorrow and with your test coming up later this week.